Hello everybody. For this lesson I want to work on the inverse of sine, cos and tan. The inverse of sine, cos and tan is a way of finding an angle which is unknown in a triangle given two other sides. The sine, cos and tan ratio is used exactly the same way as in the previous lessons. However, what we do is we substitute two values into the equation and we work backwards to find the size of an angle. The inverse of sine, cos and tan is written as sine to the minus 1, cos to the minus 1, or tan to the minus 1. And as for all the other calculations, remember that to make sure your calculator is turned on to degrees. Okay, for this example here, we've got a triangle and we're given two sides, 7.2 centimetres and 3.5, and we're asked to find the angle theta. Now, the sides that we've given are the opposite and the adjacent. So, opposite and adjacent, my ratio is going to be my tan ratio. So, tan of theta is equal to my opposite side divided by my adjacent side. So, I simply write down tan of theta is equal to, now the opposite side comes in at 3.5 centimetres and is divided by 7.2 centimetres, which is the adjacent side. So on the calculator, we work those out. So therefore, tan of theta is equal to 3.5 divided by 7.2, and I round to 4 decimal places. So we get 4.8 or 0.4861. Now to take the inverse to find the angle, I write down theta is equal to tan to the minus 1 of 0.4861. Now when you calculate a keyboard, you'll find that usually up behind the tan button, so you might need to press a shift to get it, or if it's on a scientific calculator or the graphics calculator, you'll find it below, tan to the minus 1. So you simply press that key, put the value in, and it gives you the size of the angle. So I worked out to be 25.92 degrees as the size of the angle for theta. Okay, for example number 2, I've got there two sides unknown, or two sides known, sorry, and an angle. So I've got the hypotenuse and I've got the adjacent. Now the two sides there, they give me the ratio of cos of theta is equal to my adjacent side, ADJ, divided by my hypotenuse. So once again, therefore, cos theta is equal to my adjacent side is going to be equal to 10.9, and I will divide that by my hypotenuse, 14.2. So my calculator, therefore cos theta is equal to 0. I round that 7676. Okay, so to work out the angle, I've got theta is equal to, this time, cos to the minus 1, or the inverse of cos, of 0.7676. So I put that in to my calculator, I find my inverse function, and I select it, and I get theta is equal to 39.86 degrees. And the last example, in this one, we're given the opposite and we're given the hypotenuse. So my ratio, I'm going to use my example number 3 is going to be my sine. So sine of theta is equal to my opposite side divided by my hypotenuse. And I substitute my values in. My opposite side is 500. My hypotenuse side, 824. Work that out. Sine theta equals 500 divided by 824 is 0.6068. So I round that to 4 decimal places. And then my theta is equal to sine to the minus 1 of 0.6068. Okay, so I'll put that in my calculator, hit my inverse button, and I get 37.36 degrees. So there's 3 examples The first example is using my tan ratio, my opposite over my adjacent. The second is using my cos ratio, my adjacent over my hypotenuse. And my third is my sine ratio, which is my opposite over my hypotenuse. So would you please have a look at the problems on page 54, practice some of those using your inverse keys, decide which one of the trig ratios it belongs to, substitute the values in, and then work out the size of the unknown angle. Thank you.